Hello, ladies and gentlemen, and welcome back. I hope you're all doing well and you're ready for more of our COMC, Canadian Open, from 2013. We're going to be starting B part of the contest, where you still just need a final answer. The questions are going to be a little harder, and they're going to be worth 6 marks accordingly. Now, if you haven't tried Part B, once again, you can get a copy of the contest by clicking down below. I would encourage you to at least try the 4 questions in Part B before watching any further in the video series. And having assumed that you've done that, if you want to, let's take a look at B1. That's what we're going to be looking at in this video. So B1. Given triangle ABC, XY are points on side AB with X closer to A than Y. And Z is a point on AC, so that XZ is parallel to YC, and YZ is parallel to BC. Looks like we've got some similar triangles here. This one might be a similar triangle. I don't think that one's a similar triangle. Maybe, but then we might also have this big one and this one here. Those should also be similar triangles. And similar triangles. There seem to be a lot of sort of overlapping similar triangles. Anyway, let's, before I mess up the picture too much, what's the question actually asking for? So suppose AX is 16 and XY is 12. Determine the length of YB. So I definitely think similar triangles is the way to go, considering I couldn't finish reading the question without drawing a whole bunch of them. Just need to get the right similar triangle involving YB or XB or AB, and then subtracting 12 or 28 or something like that. Okay. So, the name of the game is Similar Triangles and Ratios. Let's draw a copy of this picture. Erase that and draw this in. Okay, I think Z, X, Y, B, C, A. I think that's our picture. Yeah, there it is. Okay, so parallel lines, which means the angle that we hit is the same here, and this angle here is going to be the same. We've got another set of parallel lines. We also have this nice big common angle up here at A that we might be using. Also, these angles are the same. And then what else have we got? With the other set of parallel lines, we've got these two purple angles are the same, and the pink angles are the same. So let's take a look. So AXZ is similar to AYC. AYZ is similar to triangle ABC. And then, since it's the difference of the purple and red, we get the same orange angle here. So, triangles XZY are similar to, and when you're writing these things down, remember it's a B part, we don't actually have to be justifying anything, we just need the final answer. But when you're writing these down, you want to keep the order so that the angles, the common angles, match up. And so Y and B have the same angle, and so on. It makes for listing ratios a lot easier. So XZY is similar to YCB. And then can we do the same thing with the... Not quite. There's no extension down here for a full angle. Although maybe we'll draw that in. But we've got a lot to work with. Now we want YB. So YB is to Y to XY, I think. As YC is to XZ is to BC as YZ. So this all comes from this expression down here, and I want to keep an wrong direction. I want to keep an eye on YB because that's the length that I want, and that's what we're looking for at the end. Okay, so looking at this pair of triangles, we also have things like AY is to AB, as AX is to AC. I feel like I have the order wrong. Oh, there's no X. It's AZ is to AC. Okay, there we go. Is to YZ to BC. Oh, now I have this ratio here, so there's an inverse. So if I actually flip this the other way around, BC BC is to YZ. Okay, they really did. BC is to YZ what AC is to AZ is AB to AY. So that means that they're also equal to YB over XY. Just as an example. And then can we do something similar? AX and AY, YC. Oh, AY is in both of them. AY. AC and AZ is also in this pair. That's what we're looking for. So, I keep hitting the wrong buttons. So AC to AZ. AC is over AZ. So AY is over AX. And then YC over XZ. And so therefore this is also YB over XY. So we get the same ratio everywhere. We could even call it R. Okay, so the question is, I need to keep an eye on YB, and I need it in terms of the lengths that I know, AX and XY, and also AY is something I know it's 28. So let's get the green out and say 16, 28, or sorry, 16, 12, and 28. Alright, so where is AX? It's down here. And that's it. XY is right here, and right here. And back up here, I guess. But that's about it. And AY is 28, and that's right here. And right here. And there we go. YB to XY is the same as AY over AX. So AY is 28. 28 over AX, which is 16, is YB over 12. Which is XY. Just double check. XY is 12. AX is 16. So AY should be 28. Alright, so we're good. So 28 times 12 is the same as YB times 16. Divide by 4 and 4 on both of them, so I get 7 times 3 is YB. So YB is 21. And there we go. So it was basically just chasing the lengths and ratios around these triangles. The parallel was a big hint that we were going to get similar triangles in there. And then you saw me, I just set up every ratio I could think of, and then I went through with a different color pen or a highlighter and highlighted specifically the things I knew. I was looking for ratios that had both of two things that I knew, because we wanted YB. We only had one ratio with the YB. It was YB and XY together. So I knew one of those, I didn't know the other, and I wanted it to be equal to a ratio where the other two things were known. So I had one equation and one unknown. And there we go. Fine way to start off B. It was B1, so up next will be B2. Feel free to stick around and look for that in the next video. Until then, take care and have a wonderful day.